Example time. So, we need to pause and we need to look at these examples and we need to understand really what these questions are asking before we move on. Because the next portion of the lecture is going to start concerning reactions. And I don't know about you, but if I had a choice between classification and reactions, classification is probably going to be a little easier. And I want to make sure I can answer the classification questions correctly because I might have a little bit more difficult time in the reaction portion of the carbohydrates. So, we want to pause, take a deep breath, make sure we know what these questions are going to be asking so I don't lose out points that are unnecessary. So the first example is going to say draw L-urethros. And this is going to go back to the whole term of kind of an enantiomer in a way. So on the chart that I've just shown in the past two videos, we can find the structure of not L-urethros, but we can find the structure of D-urethros. Not only that, but D-urethros, I said, should be one of those structures that you should have memorized. So by the test date, D-urethros, you should be able to write down without looking it up in a text. Alright, so what's the structure of D-urethros at least, right? L's not given, but we can at least do the D. Well, this is a aldose, so it's a C double bond OH at the top, and then we have a CH2OH at the bottom, and then urethros has the OH groups on the same side of the molecule. So this is D-urethros. So I'll draw an arrow and I'll say this is D-urethros. Okay, so how do I draw the L version? Well, D and L, R and S, left hand, right hand, right? And we said that you take a molecule, you do the mirror image of that molecule, and when you do the mirror image of it, you get the opposite version. Okay? So when I do D and L, you've got to be very careful. I see people trip this up all the time. So basically what happens is that they're asking for the enantiomer of that structure. Once I take urethros, do the mirror image, flip it. Okay, so C double bond OH and then CH2OH at the bottom. And what happens is that this OH group will flip as well as this OH group flips, right? The C double bond OH, that doesn't move. I mean, that's at the top. That's kind of the head. The CH2OH at the bottom, that doesn't really flip either. It stays at the bottom. There's no left-hand side and right-hand side for those. The only ones that get left-hand side and right-hand side are the OHs and the H's. So this, ladies and gentlemen, is the structure for L-urethros. What I don't want you to do, the mistake that people do all the time, is they believe that the only thing that they have to do to change this into an L-urethros is to take this OH group at the bottom and flip that one only. The problem that happens here is that that is a L sugar. You are correct, it is an L sugar, but it's not urethros anymore. Right? Urethros had the OH groups on the same side. So if you only flip this one to the left-hand side, your OHs are now on opposite sides. And that's not urethros, that is threose. So what you've done is that you've given me the structure of L-threose, not L-urethros. So you really have to flip the entire molecule. All of the OH and H groups have to be flipped. Every single one of them. I can't stress it enough. So to draw these L forms or the D forms, when you flip the sugars, left hand and right hand, you have to treat all of the carbons, not just the last one. If you only flip the last one, then you change the structure of the sugar itself. And in this case, it will not be urethros anymore. It will be urethros or threose if that's the only one that you flip. So all of them have to be flipped around. Don't forget it. Don't lose out on those simple points. Okay, so number 2 says, what sugar is the C3 epimer of D-xylose? Alright, so on a test, I did not require you to memorize D-xylose. So what would happen is that I would give you the structure for D-xylose. So I'm going to come over here to the side and write number 2. D-xylose is a C double bond OH up here, and then we have a CH2OH group down below, and xylose has 3 chiral carbons, and the structure of xylose has an OH to the right, and then an OH to the left, and another OH to the right. Okay, so there's D-xylose. So we want to know what sugar is the C3 epimer of that structure. Alright, so let's take a look at where the C3 epimer is at. So here's carbon number 1, carbon number 2, and carbon number 3. So this is the C3 epimer that's important. Okay, so I'm going to draw that in a different color. That means that this carbon needs to be flipped for me to identify what that sugar is going to be. So I take my OH group and I take this H group there and I just flip their sides. So OH and H. So this is the structure that I need to find now on the chart of aldoses, right? So this OH group is on the same side as the others. I tried to find that structure in the chart. So let's go back and take a look at that chart maybe. So this was the chart for the ketoses, and this was the chart for the aldoses. So here's D-xylose. I've taken this C3 epimer, OH is now on this side, and in this row, right, that's where my answer should be. I've not deleted carbons, I've not added carbons. I should be able to find a structure that has all of the OHs on the right hand side. So this one's not it, that one of course is not it, this one's not it, but lo and behold, look, we see a structure that have OHs all to one side, so that means that D-ribose is the C3 epimer of D-xylose. So D-ribose is going to be the answer here. So there's the structure, and if I were told to name it, and I do, what sugar, they want to know the name, that sugar is D-ribose. The same thing is going to happen with structure number 3, or example number 3. So I'm just going to scroll down, do another arrow again, and number 3 says, what sugar is the C4 epimer of D-lysose? Alright, so I need to know what structure D-lysose is. So I go to this chart, and here is lysose, and I'm just going to copy that structure down on the sheet of paper, right? So C double bond OH, and then down below CH2OH, and for this thing to be lysose, the first OH is to the left, the second OH is to the left, and the third OH is to the right. So there is lysose. Now the question says, what's the C4 epimer? Alright, so I need to pick out my fourth carbon. Carbon 1, carbon 2, carbon 3, carbon 4. It's right here. And at carbon number 4, I need to flip the position of the OH and the H. Alright, so OH and the H. So I go back, and this OH is going to show up on that side, and the hydrogen is going to be there. Okay, so we have a little bit of more complicated task on our hand this time around, and the reason is because look at what has happened. The last OH group has went from the right hand side to the left hand side, so no longer do we have a D sugar anymore. And if you look at this chart are nothing but D sugars. Okay, so we've got to go a little step further here with this example. What I have just drawn, Epimer-wise, is a L sugar. And I've got to figure out what L sugar I have. The reason I know it's an L sugar, again, is because this OH group, that's the last one, it's on the left-hand side. So, again, this chart, it's only D's. No L's are going to be found here. Okay, so how do I answer this type of question then? Well, look at your OH groups. The OH groups are all on the same side, right? So it's the same side, same side, same side. So out of that family of sugars, right, 1, 2, 3, 4, and 5 carbons in total. Well, 1, 2, 3, 4, 5 carbons in total. This is the family of sugars that are your choices. Which sugar out of the bunch has the OH groups all on the same side? Well, here they're on different sides, here they're on different sides, here they're on different sides, here though they're all on the same side. So that means that the C4 epimer in this example is going to be ribose, but it's the L form of ribose. This is L-ribose. That's going to be the C4 epimer. And again, look, the OH group is left-handed. So if I asked you to draw from D-ribose the enantiomer of L-ribose, or if I said, draw me L-ribose, what you would have done is that you have taken the D version and you would have flipped everything over, right? You would have taken the mirror image, just like we did in the first example. Well, all of the OHs and Hs switch places, and that would force all of the OHs on the left-hand side. So once again, look at your OH groups. They're all together on one side of the structure, and that makes it ribose. And this OH group down here below, it's to the left, so therefore it's the L version of the sugar. Number 4, the last example. How many stereoisomers could an aldoheptose have? Okay, so here's the thing here. To calculate the number of stereoisomers, it's really 2 to the nth power. And 2 to the nth power, what does the N stand for? N stands for the number of chiral carbons. So in a previous video, we said that if the molecule has 2 chiral carbons, then the stereoisomers that it would have would be 2 to the second power, which is 4. If it has 3 chiral carbons, it's 2 to the third power, so that's 8. If it has 4 chiral carbons, well, this is 2 to the fourth power. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So we need to figure out how many chiral carbons an aldoheptose would have, right? Okay, so an aldoheptose, here's the aldo, and then down below is my CH2OH, so there's 2 carbons. 3 carbons, 4 carbons, 5 carbons, 6 carbons, 7 carbons, and each one of these are chiral all the way down. They all have maybe OH groups on them, and they all have H groups on them. Maybe they're all on the same side, who knows, that doesn't really matter. But you've got 5 chiral carbons. This one, not chiral. This one, not chiral. So 5 chiral carbons, 2 to the 5th power, well, that's 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 16 times 2 is 32. So we would have 32 stereoisomers that would come from an aldoheptose. So again, it's 7 carbons total, but only 5 of them are chiral, and those are the ones that get included in that equation of 2 to the nth power. Alright, so next up are reactions for carbohydrates. So get a drink of water, come back, be ready.